Okay, first question is about rates of change. When getting a ride in a taxi, the cost is determined according to this formula. And it says, so C is the total cost in dollars, and D is the distance traveled in kilometers. So the bigger D gets, the bigger this whole thing gets, and the bigger your cost is going to be. That makes sense. The further you drive, the higher the cost. Is it linear or nonlinear? Well, it's linear. Make sure you're checking your answers here and fixing any mistakes. It's linear. If it says to give a reason, you say something like there's a constant rate, but it's linear because this is the equation that we've worked with all year. So it's very familiar to us. It's got the change and it's got the initial value. There's no exponents, so it's definitely linear. State the rate with units. So where's the rate? Looking at the equation, remember what I said yesterday? There's four ways we talk about relationships. In words. There's words in this question, but this one isn't in words. The equation. This one gives you the equation. A table and a graph is the fourth. Okay, so this one's giving us the equation, so we need to be able to pick out the rate and the initial value from the equation. And how do I do that from the equation? The rate is the thing that's beside the variable, like that. So it's 2.75, and what are the units? It's whatever something per something. You got to know that the units for a rate is always something per something. So this one's dollars per kilometer. What does the rate represent in words? Cost per kilometer. It's kind of just writing out the unit in words. State the initial value. So the initial value is the other number that's not multiplied by a variable. So that's 5, and with units, it's $5. You think to yourself, did you get that right? Do you understand what every one of those questions is saying? Did you include units? Did you know what the units were? All those things, because again, the exam's going to look very much like these questions that we're taking up, right? So make sure you can have this moment to reflect on how well you did with this. What does the initial value represent in word? The initial cost. Initial value means initial cost or fixed cost. Cost when you step into the cab, something along those lines. Now, I told you the other day that there are no ratios, rates, proportions, or percentages on the example. We'll take these up anyway. It's good practice. Proportions is a really important life skill. How do I convert a fraction to a percentage? 3 divided by 8 times 100. 3 divided by 8. Before I do it, when I look at that fraction 3/8, what do you think about that fraction? 3 divided by 8, that's good. See, I think 3 out of 8, which I think is like almost 4 out of 8, which would be a half. It's just under half, right? 3 out of 8, like that's a good, if you can understand that about fractions, you're pretty good, okay? So 3 divided by 8 should be just under half. What's half as a percentage? 50%. So times 100 equals, so 37.5%. That's just under half. If I got some number like 80, I'd be like, wait a minute, that doesn't make any sense. 3 out of 8 is less than half. So mine should be less than half, but not too much less than half, right? 44 out of 47, that's the same as 44 over 77, so we do it the same way. %57 and 0.04. There's different ways that you can do this one. You can multiply it by 100. Whoops. You can just move the decimal 2 places, but this one is 4%. Yep. I wonder if you did 77 divided by 44 by accident, maybe, right? We want to do 44 divided by 77. Andrea can knit 2 hats in 5 days. How many hats can she make in 40 days? There's different ways that you can do this. Because 5 is easily scalable up to 40, you might be able to just kind of wing this one and figure it out, right? Because she can do 5 days 8 times in 40 days. So I do 2 hats every 5 days would be 16 hats total. But if you wanted to set this up like a proportion, I do 2 hats in 5 days. So this is hats and this is days. How many hats? So that's my variable in 40 days. And the little trick is x equals 2 times 40 divided by 5. And then you plug that into your calculator, it works out 16. If it's scalable, 5 to 40, do it that way. If it's not scalable, we want to know how to do it this way as well. Grade 10 course has a lot of proportions in it and a lot of other things that look like a lot like proportions. So it's a really good thing to be able to do this formal math as well as just understand that idea of scaling. Okay, and last question. Again, this is a pretty good life skill. A pair of pants is selling for $74.99. What will the pants cost after taxes? Most people kind of just know it'll cost a bit more. And so like, oh, it'll be $80 something. I can afford that, so I'll buy it. But if you can at least do that, that's good. Like if you're standing in a store and you know this with taxes is going to be 80 something, not $150, that's pretty good. Most people don't pull their calculator out of their pocket to calculate the exact amount of tax. But some people who find themselves in really tight budgets definitely do that. So knowing exactly what to do is a really good thing. So let's calculate taxes first. Do you remember what taxes is? 13%. So that's 13 out of 100 times 74.99. So again, I do 13 divided by 100 times 74.99. And I get 9.75. The 8 here rounds the 4 up 1. So this is 9.75. And so then the cost, what do I do with taxes? I add it on to the total cost. Is 74.99 plus 9.75. So there you go, 74.99 plus, whoops, that was wrong. What happened there? 74.99 plus 9.75. 84.74. So $75 is about $10 in taxes. That's useful to know if you could possibly remember that, because then you could kind of figure out other versions of that, right? It costs you about $10 extra. When you're doing something like buying a car or something like that, taxes gets to be thousands of dollars, and it makes a really big difference, right? Okay. Dan leaves school walking home. He realizes he forgot a book he needs, goes back to school to get it. He spends a few minutes at school getting the book, then runs home. Draw a graph of Dan's distance from home in the space below. So first thing I'm going to do is draw my axes in. So this is distance from home. And this is time, probably in minutes. If Dan leaves school, everybody look up here. Where would school be on this axis? If Dan leaves school, but this axis is distance from home, where do I start my graph? Thank you, near the top. Near the bottom would be home. Some people will automatically start their graphs at the bottom, just because. I want to start it somewhere near the top. Okay, so he starts walking home. What does that mean? That means my distance to home is getting smaller. If he walked away from his home to Tim Hortons, then maybe my graph would have been going up like that. But in this case, it doesn't. It goes down. He realizes he forgot a book. He goes back to school to get it. So I got to go back to school. So I'm going to make sure when I go back to school that I'm about at the same height here, right? Because that's where school is. So it should be at about the same height there. He spends a few minutes at school. What does a few minutes not moving look like? Flat line. Then he runs home. So what do I have to make my last line look like to be running home? Very good. Steep. Steeper than the first one. It doesn't say about the middle part how fast he was going. I made it a bit steeper. But this is steeper. So the things that you're looking for in a story graph is the steepness of the line representing speed. He's walking home, so it's slow, it's not steep. He's running home, so it's faster, so it's a lot steeper. Where does it start? Where does it end? It better end at home. And there's almost always a flat part to show that no movement we represent with a flat horizontal line, because time is passing, but the distance isn't changing. Any questions about that? You okay there, Jamarli? You with us still? This last one I talked about yesterday, and I said we were going to do an example of this, so here we go. This is something that's really important. You need to know this for the exam on Friday. I'm telling you right now, there are a few questions like this on the exam. Justin? Yeah, you want to tell me what to do? Yeah, very good. So I got to look at the change that's happening in the table, and I'm going to look at this here. This is up 100. I'm going to do this first. Up 100, up 100. But I'm also going to look at the other side and notice this is up 2, up 2, up 2. First of all, it says determine the equation for the relationship, and then what might this table represent? So we'll do that at the end. So we're going to determine the equation first. To make up an equation, remember we talked about this? C equals something times n plus something. We got to fill those two things in with the initial value and the rate. So, go ahead. Yeah, good. Just let me stop you there. And hopefully things are nice, and I can just go back to get to 0. But just take a look. These numbers are all the same. I'm going up by 2, and then I go down 2. There were a couple of questions throughout the year that were even harder than that, because you had to go down 2 twice to get to 0. So you have to look at the numbers and think. Okay? Does it give you 0? If not, you have to find it and make sure that you actually go down the right amount from whatever it starts at. In this case, it's at 2, so I have to go down 2 to get to 0. Okay? And going down 2 in this case means going down 100 from 200 is 100. So my 0 is 100. Which line do I put that on? The second one that has no variable. Now to find the rate, what do? I take this number and I divide it by that number. And again, some people forget that and they just take this one, but you have to divide by that one. So that is the rate is 100 divided by 2, which is 50. C equals 50 n plus 100. What do you think this might represent? There's no right or wrong answer to this. I mean, if you said renting a spaceship to go to Mars, that's probably wrong, because you couldn't rent a spaceship for that cost. They cost billions and billions of dollars. If you said, rent a famous actor to come and wash your dishes after dinner or something like that, that's probably not true. They're going to cost more than this. So try to make it reasonable, but what could this represent? Absolutely. Renting a trailer or a truck or something like that. Yeah. Anything else? Tools. So those are some of the ones that we talked about. Or like a jet ski maybe. They cost a fair bit of money. And a fancy tool in particular could cost this much money. If you're just renting a small tool, it's probably going to be cheaper. And I wouldn't mark you wrong if you said any of those things. Anything else? Renting a car, maybe? Yeah, could be. Yeah, renting a restaurant, absolutely, or a room in a dining hall or something like that. Absolutely, they might do something like that. The big banquet halls, we talked about this, are often an upfront cost and a cost per person. But even if you said that, I probably wouldn't mark you wrong because there might be one somewhere in the world that does it per hour, so who knows. Okay, is that the last question? It is. Any questions about that? Everybody good?